Hi, I'm Bill Burdett, SMSC Applications Engineer supporting the UCS1001 and 1002 USB charger emulation devices with port power switch. Today, I'll be discussing the frequently asked questions that I have received in the support of this device in various applications. What happens in an overcurrent or shorting scenario with the UCS1001 and 1002? Both products have two types of fault handling. You can simply trip upon the fault detection, which opens the power port switch, asserts the alert pin, and waits for the user to reset the fault condition, or auto recovery. I'm first going to demonstrate the trip fault handling mode. What I have set up here is a UCS1002 EVB connected to my breakout board so I can measure current and voltage of the V-bus. And then I have a 60 amp knife switch connected by 10 gauge wires so I can get a really good short fast to the V-bus pin. The device has been configured for trip mode fault handling. The blue trace is the V-bus voltage, the pink trace is the current. What you will see is in approximately 1.5 microseconds, the UCS will detect the fault. The V-bus voltage will drop to 0 and the alert pin will assert. When I remove the fault, the device will wait for me to clear the condition. So I've applied the short. You can see that the V-bus voltage fell to 0 volts. The current is still relatively at 0 amps, and the alert pin is asserted. This is the trip condition. The power port switch is open and will remain open. After I remove the short, the V-bus voltage remains at 0 volts. The alert pin remains asserted. The UCS1002 is awaiting for me to reset the device, which will clear the alert pin, force a V-bus discharge, and return the V-bus voltage to 5 volts. The second mode of fault handling with the UCS1001 and 1002 is an auto recovery mode. The UCS device will detect the fault condition just as I demonstrated in the trip mode within 1.5 microseconds or so, but then we'll source a small test current of approximately 150 to 160 milliamps. This small test current will be on the V-bus pin as it's looking for the V-bus voltage to rise above a threshold. That way the device can detect when the fault condition has been cleared and then auto recover. The alert pin will go off and it'll be ready to charge or apply an emulation or whatever the device is configured for. The setup is the same as in the trip mode, and I'm going to go ahead and apply the short. Currently the V-bus voltage is setting at 5 volts and the current is at 0 amps. I'll apply my short and you can see immediately that the V-bus dropped to 0 volts, and we have our small test current here of approximately 160 milliamps. The UCS is placing this small test current on the V-bus pin and looking for the V-bus voltage to rise above the threshold to recover from this short condition. The alert pin is remaining asserted while the short's in place. Once I remove the short, the test current goes away because the V-bus has now risen above the threshold. It's returned to 5 volts. Also, the alert pin is now deasserted. So the unit is ready to begin applying a charger, emulation, or whatever the configuration was, and returns to the normal operation. It's very simple, it's very straightforward, and it's what I've been recommending in a lot of the applications.
For more information, visit smsc.com.